Hi, and welcome to Mr. Franklin Explains Some Math. Today we're doing a quick review of how to estimate the mean and standard deviation from a histogram. So, we'll start with an example. Students in a drafting class were asked to draw a design with a perimeter of 98.4 centimeters. Below is a histogram of the actual perimeters of the students' drawings. So what we need to do is estimate the mean of this histogram, and we do that by picturing this as a 3D item that we can pick up and balance. And hopefully you can see that the balance point would simply be, for this one, right in the middle. So I would estimate the mean to be 98.5. This works because the highest point on the histogram is right in the middle rather than off to the side. When the highest point, in this case known as the mode, is right in the middle, it's called a normal distribution. Normal in this case means the same thing as approximately symmetric. If the mode was off to one side or the other, it would be called skewed data. There's other ways that this can be arranged, but those are the ones that we're worried about right now. So, in this chapter, we're worried about mostly normal distributions. Here's another example. For a chemistry experiment, students dissolved a powder in a solution. The time it took for the powder to dissolve for different students was recorded in the histogram below. Estimate the mean of this distribution. I'm going to give you a few seconds to work on this yourself and think about it. Pause the video if you need more time and then come back to it. So I'm going to pick up this arrow and I picture with my mind's eye where the center of this is going to be, and I believe that the balance point would be right here at 13. I'm going to estimate the mean at 13 seconds. Now, a word about estimating. If the actual amount was, say, 12.5 seconds when we calculated it, that's okay. If two students estimate slightly different values, that's also okay. We're talking about an estimate and an approximation here. So I'm going to say 13, right in the middle. Hopefully you got something close to that. For our next task, we are going to estimate both the mean and the standard deviation for this. We're going to start by estimating the mean, and then we're going to talk about the standard deviation on that. In this example, the histogram displays the heights of female college students at Penn State in the 1970s. We need to do three things here. So I have three little arrows. The first thing is we need to estimate the mean. Same technique we used. We think about the balance point. I'm going to estimate this at, say, 64.5. Looks like a good balance point for this graph. Now, in addition to the mean, we're also going to do the standard deviation. Standard deviation is the distance above and below the mean, which would encompass 2/3 of the values. Each of these towers, or bins on the histogram, represents a certain number of data points, and we can estimate where the middle is, the middle 2/3. So we're going to have a couple of other arrows on here. We're going to talk about how that gives us the standard deviation. So I'm going to estimate that these arrows should go about here. And about, let's see, right about here. Now, we've got a space between these two arrows, and the mean should be right in the middle of it. So how far apart are these arrows? It looks like I estimated the lower boundary or fence to be at 62 and the upper to be at 67. So that is a difference of 5. From 62 up to 67 is 5 spaces, but that's not the standard deviation. The standard deviation is from the mean up to one of those spaces. So that tells us that that means that the mean should be half of 5, so 2.5. So here, I think I just said that the mean would be 2.5. I apologize. It's the standard deviation would be 2.5. So from 64.5 up to 67, that is plus 2.5. From 64.5 down to 62, that's minus 2.5. So the standard deviation is 2.5. Now it's going to be your turn. This histogram displays the running times for the Boston Marathon in the 50 to 59-year-old women's division in a certain year. You're going to use the arrows and your imagination to estimate the mean and standard deviation for this. I'm going to just fit this graph a little bit better so we can see it. And looks a little bit like a skyscraper. But we're going to think about where these 3 arrows would be placed. So use your imagination to come up with where these values should go. We've got the mean, and then 1 standard deviation below the mean, and then 1 standard deviation above the mean. And those fences for the standard deviation should encompass approximately 2/3 in the middle of all the values. I'll give you a few seconds for that. Pause the video if you need to. So it always starts with the mean, and it looks like the mean here is going to be right in the middle. I think it's a little bit below 250, but above 240. I'm going to guess 245. So 245 is the mean. Again, that's an estimate. And then the lower bound, where it looks like this would go, I think, right about there. I'm going to call that 215. And then up here, that's 250, 260, 270. Right about there. How about 275? Looks like it. So from 215 up to 275, of course, that's a distance of 60. And in this case, this is minutes of time run in the Boston Marathon. So half of that is 30, which makes sense because 245 up to 275, that's a jump of 30. And 245 down to 215, that's also a jump of 30, but in the negative direction. So here we would say the standard deviation equals 30. This distribution has a mean of 245 and a standard deviation of 30. Hopefully this helps. There will be some example problems where you're expected to do this on your own so that you get some practice. Thank you very much, and now go do some math.